Minimal APIs in .NET 9. Why use a minimal API as opposed to a full API? A minimal API is suited for a small API with just a handful of endpoints. Typically, it's manageable within a single file. The full API pattern, with controllers, services, data access, models, etc., helps to manage and maintain larger APIs. Think in terms of an API where its endpoints can be arranged in more than one logical section. For example, endpoints for the HR section and endpoints for the sales section, etc. In this video, we'll demonstrate implementing a minimal API in .NET 9. We'll create a normal ASP.core web API. But to create a minimal API, we need to untick using controllers. With minimal API, your endpoints live in the program.cs file. Here we see an example of a GET endpoint. The app uses the map get method to define a GET request. It specifies the endpoint's URL, then uses a lambda expression to define what will be returned by the GET request. Then, just for good measure, at the end it uses with name to give the endpoint a name. Let's see this endpoint in action. For those who remember Swagger from .NET 8, Swagger is no longer supported and not included with .NET 9. Instead, we have an HTTP file where we can create and send test requests to the API. Later in the video, we'll demonstrate how to implement a similar alternative to Swagger. For now, let's look at the HTTP file. Here's a sample GET request that goes to the local port and specifies the weather forecast URL we defined in the map get method. To test this, first run your API, then click on Send. The response will be displayed. We'll be creating our own minimal API endpoints so you can remove all the sample weather forecast stuff. We're going to keep this demonstration simple, so we're not going to use database access and a data context and so on. We'll just set up some temporary data. We create a student model class right here inside the program.cs file. Of course, this could be defined somewhere else, like in a models folder, etc. A bit up, in the main method, where we removed the weather forecast stuff, we create a predefined list of students. This will represent the data our endpoints can access. Our first endpoint will simply return the entire list of students. We use the map get method and give our endpoint a URL. In this case, simply students. Then we use a lambda expression to return the entire students list. Remember to add the closing parentheses at the end of the method. Open the HTTP file again and change the URL from weather forecast to students. Then run the API and click Send. If all goes well, the API responds with the list of students in JSON format. We're going to create all the CRUD endpoints for our students list, so the next endpoint will retrieve a student by ID number. We're still using a map get method, but for the URL we include an ID parameter. Our lambda expression uses this int value and tries to find the first student with the same ID. Otherwise, it will return null. If the student object is not null, we return an OK result with the student object, else we return a not found result. Go to the HTTP file again, but instead of manually adding a new test request to the file, we're going to use the Endpoints Explorer. From the top menu, go to View, Other Windows, then Endpoints Explorer. The Endpoints Explorer should show our two existing endpoints. Otherwise, click the refresh just above. Right-click the new endpoint that retrieves a student by ID and click Generate Request. The new test request should look something like this. If it doesn't, just modify your request accordingly. The Endpoint Explorer doesn't always give you the proper full request. First, there's an @ID variable. Then inside the request, we specify with double curly brackets to use the ID variable. We'll set the ID value to 1, then run the API and send the request. In the output window at the top, you'll see the 200 OK status, and student with ID 1 is returned. If we change the ID variable's value to a student that doesn't exist, like 100, and send the request again, we get a status 404 not found. The next endpoint will add a student to our data, so we'll use the map post method. It will take a student object and add it to the list. For this method, we can simply return an OK result. Back in the HTTP file, under our Endpoints Explorer, we can see the new post request in green. Right-click this request and select Generate Request again. As mentioned before, the Endpoints Explorer doesn't automatically generate the complete request. The student object or content we're supposed to send with this request is missing. When we try to send this request, we get a 400 bad request status. Again, just a reminder, at the end of this video, we'll show a Swagger alternative that will make testing your API easier without having to use the HTTP file. The complete request should include a content type with a student object in JSON format. Now when we send, we'll get a status 200 OK. Next, we're going to update a student. For this, we use the map put method. In this example, we're passing the student's ID along with the updated student object. The ID argument is optional, and you can of course simply use the ID property from the new updated student object. Either way, we first try find the student in the list to see if it exists. If it doesn't exist, we return a result not found. Otherwise, we update the properties of the existing student with the new updated values and return an OK result along with the new student values. In the HTTP file, when we refresh the Endpoints Explorer, we can see the new put request in yellow. We'll right-click it and generate the request again. As before, we only get the basic request. We'll modify it to include the ID variable and the new updated student content. When we send, a status 200 OK is returned with the newly updated student. For the last CRUD method, we use the map delete method. Again, we're going to pass the student's ID to it and first try to see if it exists. If it doesn't, we return a not found result. Otherwise, we remove it from the list and return result OK. When we refresh our Endpoint Explorer, we see the delete request in red. We generate the request and modify it to use an ID parameter. Then when we send it, it should return status 200 OK if the student existed. As promised, let's look at a better tool to test your API endpoints. A favorite tool to replace Swagger is Scalar. Go to Manage New Get Packages and browse for Scalar. Install the scalar.aspnet core package. In your program.cs file, under the if-is development statement, include an app.map Scalar API reference statement. In your project, under Properties, you'll find the launch settings. Now, for testing purposes when running your API, you can set it to automatically open your browser to your API's local host port. Otherwise, after running the API, you can manually open your browser and browse to the local host URL. Either way, once in the browser, add /scalar/v1 to your URL. This will take you to Scalar. Here you can see your endpoints and even the models that they use. Let's test our first endpoint. Click on the first GET request, and it will bring up details about that request. It shows the curl command, but you can select other formats from the drop-down. It also shows the schema of the output to expect. Click the Test Request button and a test window pops up. Click the Send button, and you'll get a response. Let's try a request with a parameter. Click the Get Request that takes a student ID. Click the Test Request button again. This time we can see the parameter under Variables. Give it some value and click the Send button. And that's the very basics of Scalar. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.